sometimes your objects have, okay, okay. Sometimes your objects have to stay together for whatever reason. Maybe it's people, for example here, 5 people are seated on a bench. How many ways can they be arranged if there are no restrictions? If E must sit in the middle, okay, we've seen that before. A and B must sit together. So sometimes you get that situation where 2 people have to be together, or perhaps maybe you're putting books on the library shelf. If I said how many ways could I arrange 10 books on the library shelf, it would be 10 tutorial, right? But if I said you have 4 math books, 4 English books, and 2 science, and the math have to be together, the English have to be together, and then the science have to be together, that would change things, right? That would reduce your number of ways. So there's special things we have to be careful about. So let's take a look at this first one. 5 people sitting on a bench. How many ways can we arrange them? Okay, so no restrictions. What's the answer? Yeah, so what's the answer for A? 120. How'd you get the 120, Eduardo? 5 factorial, right? A, B, C, D, E, 120. E has to sit in the middle. Well, that's the identical question we just had. The consonant has to be in the middle, right? So, I mean, you could show your, well, actually, E wouldn't be there, sorry. E's my label, right? This is my label. There's only one E. There's only one person called E, okay? There's only one choice you have here. All right, so then I have 4, 3, 2, 1. So the answer gets reduced drastically. There's only 24 ways I can sit those people then, if E is taking the middle position, right? Now, what if A and B must sit together? So you're right, it's 3 factorial with a little extra bit. Why is it 3 factorial?
There's only one A and 1B, right? So times 3 factorial essentially.
So there's only one A and one B, right? So are you thinking in the slash system, or you think of A and B just kind of like, okay, so there's A and B, right? So they're basically occupying 2 seats, right? I suppose, right? But there are, let's do this, okay, I'm going to list my A, B, C, D guys out first, okay? So I got A, B, and then C, D, E. So if they have to be together, think of them as being kind of almost tied together, right? They're a group, so they're inseparable. We bound them together, so they're a group. So I really only have, if I think of them as one person, one large double person, I really only have 4 objects now. 4 objects now. If A and B are together, we kind of regard them as one, okay? So 4 objects would be 4 factorial, right? The only thing is A and B themselves can switch around, right? It could be A, B, or it could be B, A. So how many ways can 2 people switch themselves around? 2 factorial. Okay, so that would be 48. So I mean, you got the twist around, and you got the idea, right? Like that it reduces your number of people. But now they've just merged into one, so they're regarded as one person. So now you're down to 4 people instead of 5. Yeah? Because they can still hop around. A, B could be here, they could be here, they could be here, right? They're still part of the hopping around, but they're just hopping around as a group. Yeah? Okay, how many ways if they can't be together? Now this is, we kind of approach this type of question. It is a permutation related to permutations, but there's no real formula for figuring the cannot be together, not easily anyway. So what we do is we take the knowledge that we already have, or that we can figure out easily, and we just kind of do a subtraction case. So if I know that there's 48 ways for them to sit if A and B have to be together, and there are 120 ways with no restrictions, is there a way you can figure out, well, how many ways if they can't be together? Yeah, just subtract. So basically, if I take the total number of ways, no restriction, and take away the number of ways if A and B must be together, okay, if I just take out all the ways that they have to be together, the leftover is going to be the number of ways they aren't together. And that's how we do the negative case. So I have 120, take out my 48, and that's 72 ways they aren't together.
C there, the when they must fit together, if we were to do it in like 5 dashes, wouldn't it just be like 2, 1, and then 2, 1?
Let's see.
It's A and B.
So I'm going to do my 5 dashes. Yeah.
If A and B have to be together, so they're at the front or something.
So you want me to kind of, they're going to be here?
I assume, I don't know.
Okay. So let's just say A and B are here. It could be A and B or B and A, right?
Yeah. So it's 2 and 1. So it could be either A or B, and then afterwards you'll have what's left over. And then it's 3, 2, 1, right? So wouldn't it just be,
But I think you're forgetting that this little, okay, let's say, this is one chair. I'll do bubbles around all the chairs, right? A and B don't have to be at the front. They could actually be in this position too, right? So let's just say they're sitting on a big double chair. We're going to call that chair number 1. Then this is chair 2, chair 3, and chair 4. How many ways are there to arrange 4 chairs? 4 factorial, right?
yeah.
So they have to be together sitting on the same chair, we'll say, okay? They're sitting on the same chair,
Oh, okay.
yeah? So their chair could be here, or their chair could be in here, right? Or their chair could be here, or their chair could be here. 2 could be, like 1, 2, 3, and 4 can be switched 24 different ways.
It's not just 2 people sitting side by side. Oh, okay. See, that's what I thought it was. It doesn't say anything
No.
about a double chair, right? So I thought
Well,
it was
yes, technically they would be sitting side by side, right? So let's do, okay, 1, 2, 3, 4, 5. So you have your 5 chairs, right? But these chairs have to stay together. So in essence, they become one unit. These guys can move around, right? So I have, how many pieces are movable? 1, 2, 3, 4 movable pieces. Their chairs aren't anchored to the ground. They're just anchored to each other, I suppose, right? Okay, let's even say that. Their chairs have been glued together. They can't move. How many chairs do you have? 4, okay? The only thing about A and B is, yeah, they have to be together, but we didn't say if it has to be A, B, or they could switch and they could be B, A, right? That's that 2 factorial.
See, I get the 2 factorial, like, and just the 4 factorial, it should be, like, wouldn't it just be 3? You know what I mean? Because, like, it doesn't, like you said, it doesn't matter whether they're in the front, in the middle, or in the end, right?
But
Like, they have to be side by side.
these people are 3 right here. There's 3 people here. There's 3 people already here, and this, and the AB also account for a space, right? You have 3 people here, and here's your 4th.
So if they were sitting in the middle, like it wouldn't be a factorial then, kind of thing? Like they have to be 3, 2, 1, or can it be?
If they said A and B have to be, let's do that then. A and B must be together
A and B have to go together, isn't it?
and must be in the middle.
Yeah.
Let's do that. Must be in the middle. Okay. So here's A and B, right? I got 2 people, and then I have 3 more chairs, right? I guess you can't really be in the middle for, let's say they have to be in the third position, okay, or whatever, okay? So 1, 2, A and B, 1, 2, 3, 4, 5, okay? Then you have 3, 2, 1, 2 factorial. Then you have 3 factorial, 2 factorial, 2 factorial for A, B, or BA, right?
Yeah, that's what I'm saying.
Yeah.
I don't know what the 4 factorial is.
Well, the 4 factorials, because I said they can't, I didn't say they had to be in the middle, right?
Yeah.
You're anchoring them. If you're going to anchor them, yeah, it's 3 factorial, 2 factorial. I didn't anchor them. You anchored them, I think, and said, okay, well, they got to be first. Then it's just 3, 2, 1. But they're not anchored. I said they could sit anywhere, right? So it's 4 factorial. 1, 2, 3, 4. Because their chair can move. It's only 3 factorial if you're going to say that they have to be in a special spot, right? Let's do this. We got 2 more grouping things coming up, so let's see if that. Okay. How many ways can 4 girls and 3 boys be arranged if a boy must be at each end? Okay, we saw this before. So I got a boy here and a boy here, right? 3 and 2. Okay, only 2 boys are sitting down though, right? And I had 7 people in total, so the middle should be 5 factorial. 720. Okay, now here we go. The boys have to be together. I'm not saying, so the boys act as a group. They act as one initially, okay? So this means we only have, okay, I've got the 4 girls and the 1 group of boys. 4 girls, whoops. And 1 boy. And I'm going to put quotes around there. I know we don't just have 1 boy, but when you group the boys together, they're acting like a boy, 1 boy, right? They're acting as one. So initially I have 4 girls and 1 boy. So that's going to be 5 factorial. Okay. Now within the boys group though, they can sit anywhere they want in that little group. So 3 factorial. Yeah, we got the same answer, right? Okay, does that sort of make sense? No? Because you only have, now you have girl, 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 and just to kind of make it not really huge, but I'm going to say 1 big boy, because they're all grouped together now, right? So how many ways can I permute that set of people? 1, 2, 3, 4, 5 factorial, right? If I really look inside this big B, there's actually 3 little boys. 3 little, right? 3 little boys. So those 3 little boys could be twisted around 3 different ways, right? 3 factorial, I should say. Okay, what's the next one? The girls have to be together. Okay, you respond to me. What's the answer to that one? The girls have to be together. The girls act as a group or act as one.
So 4 factorial multiple 576.
Yeah. So the girls act as one. So then I have 4 factorial, 4 factorial. And so I would say here 3 boys and 1 girl. That's this first thing. And then this is the permutations of the girls themselves inside their group.
576.
Thank you. Okay, this might get the point across maybe best of all. We'll see. The girls must be together and the boys must be together. So the girls act as one, the boys act as one. So how many objects do you have to permute? 2 objects, right? Now within those groups, how many members do you have? 4 girls, 3 boys. This is the group of girls and the group of boys. Oops. Yeah, 288. And then last grouping question, it's the same, it's virtually the same as the boy-girl, except you're talking about vowels and consonants, but it's the same concept. It's really the same question, really. How many ways can the letters of the word audio be arranged if each arrangement must begin with a vowel and end with a consonant? The vowels must be together, the vowels cannot be together. So let's see. That's an interesting word, right? I guess we should decide first, or just establish, how many vowels are there? 4 vowels and 1 consonant. So, begin with a vowel, end with a consonant. Well, there is only 1 consonant, right? So it's just 4 factorial. Okay, I'm going to let you figure out B. The vowels must be together. be together?
48.
I thought I got 48 as well. Let's see. How'd you get 24, Neville?
Oh, wait, vowels together at
48?
48.
No. So vowels must be together. So if the vowels are acting as one group, there's 4 of them. So they're 1. Then I only have one other, one other letter, right? So that's 2 groups initially. The vowels and the one, right? 2 groups or two objects, I guess we'll say. 2 objects. 1 consonant, or sorry, 1 vowel and 1 other letter, the consonant. So then within that, though, you have to permute the members of the group. There's 4 of them. So 24 times 2, 48.
That in that things, so D can be back or can be
Right.
so.
Yeah, pretty much. Yeah. 2 ways. You're right. Okay, what about the vowels cannot be together? You know how many ways that they can be together. How do you figure out the cannot?
That's
5,
Didn't we just do that up here?
5.
So what did you do, Neville? You did 5 factorial, take away the 48, right? 72? Okay, so what does the 5 factorial represent? The number of permutations of 5 letters, no restrictions, right?
Is there any way to, because a bowl should be, is a 4 vowel, how can not be,
Um,
together? I mean,
just finish this, Eileen. Okay, so we do our number of ways just to permute the 5 letters, no restrictions would be 120. Take away the number of ways they have to be together, and that should leave the number of ways that they can't be together. What was your question, Eileen?
because there is basically 4 vowel,
Yeah.
and anyway when you mix up, anyway it will be put together. Vowels will be together.
Yeah, it's impossible.
That's
Oh, yeah, you're right. Why doesn't that work, or why does it work mathematically though? Yeah, you're right, Eileen. Okay, vowels, number of ways to permute 5 factorial. For the vowels must be together. Why does that work mathematically? I gotta think about that one. You're right, Eileen. And Adam, right? Why does this work? The vowels must be together. So we've got a group of, I got 1 group and 2 groups, right? 2 factorial, 4. I gotta figure that one out. That doesn't make sense, does it? But mathematically it does, and that shouldn't work. There should be no answer to it then. Okay, sorry. I gotta figure out why that doesn't work.
So
Conceptually it does.
Are you gonna give the result tomorrow?
I'll try, yeah. Sorry, the procedure's the same, right?
Wouldn't it just be 24? Just 24. If the vowels are together, that's the same question as A. It's the same thing.
It's the day.
It's 24. And that's what I'm saying, like it should, like it would be.
Well,
like,
no,
going
because
back to the other one,
the
like,
vowel,
when-
the vowel could go here, or here, or here, here, right?
Yeah, but we only have 4 vowels to choose from, right? And they have to.
Or
be
sorry,
consecutive.
the consonant could go, the consonant was at the end, but the consonant could go here, it could go here, it could go here, it could go here, right?
No, but that's the end of the consonant, right?
It splits up the vowels.
Yeah, like in A.
Because if it's in the middle, then you have vowels on both ends.
Yeah, like in A we have the restriction that it has to be at the end, right? Which coincidentally also makes it that all the vowels are together. So in B, if our restriction get all the
Oh,
vowels
sorry,
together,
no, there is an answer, yeah, sorry.
it'd be 24.
Okay, so the only other way, yeah, the vowels don't all have to be together, right? Because it could be like this. Let's just take the actual letters too, right? So this is vowels together. Okay, this is the word, right? Okay, so it's either A, U, I, O. Those are the vowels that are together, right? So the D either goes here or the D goes here, right? That's our two. Okay. The vowels must be together. And then I can permute these 24 different ways, right? So these are permuted 24 different ways. So that gives me 24 cases here and 24 this way. That gives me the 48, right? That gives me that 48. So that's correct.
Yeah, that's correct, but the other,
And then the other one, the vowels can't be together.
that's not make sense, because there is 4 vowels.
Well, that just means this, though. That means it could be A, D, U, I, O, right? That's vowels not together.
And vowels together, U, I, O.
Yeah, but the A's not with them. They mean all the vowels together.
All about, okay.
So, or another one would be A, U, D, I, O, like we were given. The vowels are not all together. The vowels are all together, right? I could have the U here, the I here, the O here, the D here, and the A, vowels not all together. So there's 72 ways that they wouldn't all be. They mean all together, no separation at all. All 4 of them in a row.
Okay.
That's what that means.
That makes sense.
Yeah.
I thought it's vowels not together, so it's like 2 vowels.
You're right. You'll never have a word where no 2 vowels are not together. There's always going to be at least 2 together, but they mean all 4 together in the group, right? Not separated. All bonded together. That's what that question means. Okay, so that's grouping. Okay, just to clean the palette, let's just do a really, you'll see one of these. Let's go back to my original example. You have 12 library books, 4 math, 4 English, 2 science, and 2 history. How many ways can you arrange them on the shelf if they have to be in their groups? They have to stay in their groups. Okay, yeah, just shout out the answer to me. What's the procedure? I have 4 groups of books, right? So these books, they could be math, English, science, history, or I could move the math over here or over here. Like they could all be shuffled 4 factorial different ways, right? Then within the group, math can be permuted 4 factorial, English 4 factorial, science, history, right? So now you have 12 books. Same deal. How many ways if the math books have to be together? Only the math books have to be together. Only math have to be together. There's 4 of them. 4 for the math. Okay, so how many books do I have? I have 2, 4, 8, 9. 9 books. And then the math can be permuted 4 factorial. Right? Because these guys would just be regarded as separate. Yeah. Okay. So you got a couple of things to work on. You've got this worksheet I handed just because the book doesn't have any questions for you on these types. So I tried to get a random grouping. We got some permutations, just some regular ones with no restrictions, and some with letters, some with numbers. I think we got a grouping here. I think number 6 is a grouping. Answers are here. I think the answers are good. We haven't done a lot with digits. So I'm gonna say, that just do 1 through 7 for sure, unless you feel really confident, this stuff just makes perfect sense to you. Try 1 through 7, and 8, 9, and 10 we'll talk about tomorrow. I'll give you more instructions so that you'll be able to do 8, 9, and 10 tomorrow. But try 1 through 7, and then you also have that course outline that I handed out yesterday too.